Good morning, friends. So in the last few lectures we studied torsions, problems related with the torsions. So that's why because as per the exam point of view, means separate test, last article above the torsion, that is the shaft in parallel and in series. So what is mean of the shaft in parallel and what is the conditions? So that we study. Shaft in series, shaft in parallel means, suppose this is a one material, hollow portions, and this is another portion. So this is steel and this is copper. Now here's in this case, now torque is acting. So because of the torque acting here, so the torque shared, this is, suppose this is Ts or T equal to total torque equal to Ts plus Tc, total torque equal to, and angle of twist for material, for both material. So because this is parallel means common, and that is equal to theta s equal to theta c. This is the condition. So condition for shaft in parallel. So this is condition. And shaft in series means, suppose this is one end and this is another end, and here if the torque is acting, suppose this is the torque is acting and this is fixed end. So yes, T1 plus or T1 equal to T2, T1 equal to T2, and in this case angle of twist, total angle of twist, and this is total angle of twist equal to angle of twist equal to theta equal to theta s plus or theta 1 plus theta 2. So this is the condition for shaft in series. So shaft in series means T1 equal to T2, and shaft in parallel means theta s equal to theta c, or theta 1 equal to theta 2, or theta 1 equal to theta 2. So this is the condition for a shaft, and this is the condition for and after that total angle of twist equal to, this is theta 1 plus theta 2, and here total torque that is to be transmitted. So this is the torque, Ts is the torque shared by the steel shaft, and Tc is the torque shared by the copper. So here you can say Ts is the torque shared by steel shaft, and this torque shared by copper shaft. So this may be hollow or this may be rigid. So I think in the another one terms that was missing, so I think that is the polar moment of inertia, because you know moment of inertia. So moment of inertia equal to, so as you know, so this is x axis or moment of inertia about y axis. So about x axis means We are considering here, suppose this is x-axis, so this is moment of inertia about x-axis, and if this is y-y, this is moment of inertia about y-y, right? Or in this case also, suppose this is x-axis means Ixx equal to, so here you can share capital BD cube divided by 12 minus small BD cube divided by 12. So here's this is capital B, and this is hollow portion means this plus this part. So small b equal to capital B minus T, and small d equal to, and this is total capital D, small d equal to capital D minus 2t, because this is T and this is T. So this is a relation, and this is for Ixx, and similarly Iyy equal to, now so here this is Iyy, so here's yy. So by using parallel axis theorems you have to calculate, because this is not symmetrical, this part. So there the moment of inertia means this yy axis, this is not passing through this part. So here's self moment of inertia plus ay1 square plus self moment of inertia 2 a2 y2 square. Now, so here's polar moment of inertia is nothing but, so in this case suppose polar moment of, because we are studying, this is Ixx plus Iyy. So in this case Ixx equal to pi by 64 d raised to 4, and this is also pi by 64 d raised to 4. This is for solid, so that's why 64 2 into pi d4, or pi by 32 d raised to 4. So this is called polar moment of inertia. This is called polar moment of inertia. And section modulus equal to I divided by Z, and polar modulus equal to IP divided by Z. So that's why pi by 32 d raised to 4 d by 2, and this is pi by 16 d cube. So this is called polar modulus. Section modulus equal to d by, or this is y. So this is equal to polar modulus. Section modulus, that is different. Section modulus equal to I divided by y, and polar modulus means here, and this is IP divided by y. So this is the difference, and this is the polar moment of inertia equal to IP equal to polar moment of inertia. So if you have any doubts, because such type of the small theory questions may be asked during the surprise test or during the examinations also. So please try to study deeply for the surprise test, so which is held on the Wednesday. So please note down today's first problem. A composite shaft consists of copper rod. A composite shaft consists of copper rod of 30 mm diameter enclosed in a steel tube of external diameter of 50 mm and 10 mm thick the shaft is required to transmit a torque 1200 Newton meter. Determine the shear stress developed. Determine the shear stress developed in copper and steel. If both shafts have equal lengths and welded to a plate at each end so that their twist are equal. Take modulus of rigidity. Take modulus of rigidity for steel as twice that of copper. This is given. So first we'll extract what is given. So according to that, I can split this board into 3 parts. A shaft consists of copper rod. So this is copper rod 35 and this is 50. This material is the steel tube. Steel tube. So that's why area of the steel tube equal to pi by 4 into 50 square minus, this is 10 mm thick, means this is 30, because this is 10 mm, this is 10 and this is 10, so remaining 30. So we'll extract torque T equal to Newton meter, or this is multiplied by 1000 Newton mm. If the both ends length equal to length of steel equal to length of copper, and take modulus of rigidity, CS equal to, so this is twice and this is given. So first area of the tube equal to steel tube, (50 square minus 30 square divided by multiplied by pi divided by 4, this is equal to 63 mm square. Now copper equal to pi by 4, 30 square multiplied by pi divided by 4, 6.85 mm square. So here what is condition? Angle of twist, steel equal to angle of twist. Now we know formula, T divided by polar moment of inertia equal to C theta divided by L. So this is theta S equal to TS LS pi by 32. This is steel tube, so that's why 50 minus 30 multiplied by, so this is CS. Alright, similarly for copper, TC LC pi by 32, 30 raised to 4 multiplied by, this is CG. Now theta S equal to, or theta S equal to theta C. So that's why here we can write TS LS divided by pi by 32, 50 raised to 4, 30 raised to 4 multiplied by CS equal to CG, and this is TC into LC pi by 32, 30 raised to 4 CG. So this CG will get cancelled, LS LC will get cancelled. Pi by 32 will get cancelled, and TS equal to 50 raised to 4, 30 raised to 4 divided by 30 raised to 4 multiplied by TC. This is the relations which we can determine. Minus 30 divided by and this is multiplied by 2, this 2. $13.43 into TC. Now we know T equal to total torque, this is given, and T equal to TS plus TC. Now T equal to, this is 13.43 TC plus TC, and this T equal to, what is T equal to? 12 into 10 to the power 5, right? Yes. So TC equal to divided by 14.43. TC equal to this is equal to TC equal to 83,147 Newton mm. Copper equal to, or TS equal to minus this is 5 digit minus, so this is equal to so this is 83 and this is 85 Newton mm, and TC equal to 83 point, so this is Newton mm, and this is 147 Newton meter. This is equal to Newton meter. So what is to be calculated? Determine the shear stress developed in copper. Now we know T divided by polar moment of inertia, tau divided by Rs. Now we can use this relation. So tau S equal to IPS equal to, sorry, RS equal to TS IPS. So tau S equal to TS (10 to the power 3) multiplied by, this is steel tube, means 50 divided by 2 divided by pi by 32, 50 raised to 4, 30 raised to 4, right? Yes. So that's why tau S equal to into 50 multiplied by 16 divided by pi tau s equal to. This is equal to 52.28 mega Pascal. Shear stress induced in copper or steel tube, and similarly C, RC, TC, IPC. TC equal to 83147 multiplied by RC equal to this is 30 divided by 2 and divided by pi by 32, 30 raised to 4. 83147 multiplied by 16 divided by pi into 30 cube. 83147 multiplied by 16 divided by pi divided by 30 cube. So this is equal to 15.68 mega Pascal. So I will check my answer. Alright. So this is your second answer. And first answer, what is? So I think shear stress is to be calculated. So this is expected answer. So in this problem, both are fitted in the one copper tube that is fitted in the or copper rod that is in the steel tube. Now in this case, next is in the next model is steel shaft, and other is the aluminum tube. So conditions same, angle of twist that remains same. So according to the given data, we have to calculate. So what is to be calculated? So please note down today's this is second problem. A steel shaft and aluminum tube, a steel shaft and aluminum tube are connected to a fixed support and to rigid disc as shown in figure. If the initial stresses are 0, determine the maximum torque which may be applied. Determine the maximum torque which may be applied to the disc. If the allowable stress are 120 megapascal in steel shaft and 70 megapascal in the aluminum tube. G for steel 80 gigapascal and G for aluminum 27 megapascal. Sorry, this is against, this is gigapascal. So a steel shaft and a steel shaft and aluminum tube are connected to a fixed supported to rigid disc as shown in figure. As shown in figure. Okay. So in this case, this is a disc. एक मिनट है. So it is given this thickness 8 mm. This is 76. This is 76. Thickness 8 mm and diameters, I think this is 50 mm steel. This is 55 steel and this material is the aluminum. Right, what is to be calculated? This in the initial stresses are determine the maximum torque which may be applied. So in this case, in the previous case, shear stress is to be calculated, and in this case allowable shear stress is given. Now this is 120 megapascal for steel and 70 megapascals in the aluminums, and this is G for 80 gigapascal and G for, so G for steel equal to 80 into 1000 means megapascal, and aluminum equal to 27,000 megapascal. Shear stress for steel 120 megapascal, and for aluminum 70 megapascal, right? And length equal to, length is also given 500 mm. This length is given 500 mm for both. So first what may be, according to the condition, theta S equal to theta aluminum, right? So that's why theta S equal to Ts. What is basic formula? T divided by polar moment of inertia equal to C theta divided by L. So that's why theta equal to TL, polar moment of inertia. So yes, TS, LS, polar moment of inertia for S, and this is for CS, TC, LC. Okay, so this is aluminum. For aluminum, and this is aluminum. TS, this is unknown, this is 500. For steel tube, pi by 32. This is 76 raised to 4 minus 8 mm thickness. This 8 and 8, 16. So this is 60 square, or 60 raised to 4. CS equal to 80,000. Now this is T aluminum multiplied by again 500 and divided by pi by 32 raised to 50 raised to 4 multiplied by 27,000. So this will get cancelled, this will get cancelled. So what is remaining? TS divided by 76 raised to 4, 60 raised to 4 multiplied by 80,000. And right hand side, torque which is acting on all the aluminums, 76 raised to, and this is 60. $27,000. All right. Now TS equal to TS equal to so this is 9.67 to 11. This is one relation. And next, now shear stress is given. So first we'll case first if, so this is tau S equal to 120 megapascal. What happens in aluminum also? Okay, so before this is T equal to Ts plus T aluminum, and this Ts equal to 9.672 T aluminum. So plus this is T aluminum, T equal to, right? So case first, if tau s equal to 120 megapascal. Let us see what happens. Now what is relations? Divided by Rs equal to Ts divided by polar moment of inertia. So this is 120. Now steel shaft means this is 50 divided by 2, and this is Ts pi by 32, 50 raised to 4, or Ts equal to 120 multiplied by pi by 16, 50 cube. Ts equal to into pi divided by 16. This is equal to 243 Newton mm. So this is Ts equal to so that's why T aluminum, and this is equal to 9.672 T aluminum. So T aluminum torque acting on the aluminum is equal to, so this is 294,243 divided by 9.672. This is equal to 306 158 Newton mm. So yes, you can calculate tau s or tau aluminum is equal to R aluminums equal to T aluminums, and this is pi by 32 raised to 76 raised to 4, and this is 60 raised to 4. So we'll check within this is limit or not. So this is 306,158 multiplied by pi, and this is 76 divided by 2 divided by pi by 32, 76 raised to 4, 60 raised to 4. 6158 multiplied by 76 multiplied by 16 divided by pi, and this is 60 raised to 4. Right? So we'll calculate multiplied by 76 multiplied by 16 divided by pi divided by bracket 76 minus 60 bracket close equal to, this is 5 point. So 1 minute. TA equal to, so this is 27, 80 into 10 to the power 3. For aluminum. Sorry. So here we did mistake. So this is actual, this is steel, and we consider this is wrong. So that's why I am not getting correct answer. So from this step I did mistake. So that's why I have to correct this. Pi by 32 raised to 50 raised to 4 CS equal to, this is correct, and this is pi by 32 76 raised to 4 60 raised to 4 27,000. So this will get cancelled, and here I make mistake here. This is 27,000 and this is 50 raised to 4, and here this is 76 here 50 raised to 4, and this is 76 raised to 4 and 60 raised to 4. So that's why so this is 0.9076. 9076 TS equal to, so this is 1.9076, right? Now TS equal to, here's, this is 0.06. So that's why 3.245089. Right. So this is now we can check. So this is 61.56. 61.56, and this is given safe for aluminum 70. So this is safe, this is less than 70 megapascals, so means it is safe. Right. Now for steel, so this is correct. And by using formula TS IPS equal to tau S, because we consider this is 120, so this is tau S multiplied by RS. So TS, this is 120 pi by 32, and this is d raised to 4 divided by d by 2. This is pi by 16 multiplied by d cube. Now TS equal to 120 into pi divided by 16 50 cube equal to 2945 243. That is correct. So total torque equal to, what is to be calculated? Determine the maximum torque which may be. So this is TS plus T aluminum plus 3245089. This is 6.190 kilonewton meter. So try to understand this. So this much torque that can be applied. So these are the problems related with the shaft in parallels. So in the next class we will see problems related with the shaft in series, and we can wind up these chapters. So please note, on Wednesday I will conduct surprise test that is based on the torsions. So be prepared for the surprise test that which is held on the Wednesday. Thank you.